All right, this is the first part of lab 2. We have to show, we gotta do our full binary adder, testing our inputs A, B, and C in, and our outputs sum and C out. Note that this first LED is sum, second LED is C out. Our first input switch right here, number 1 is A, second input switch is B, and third input switch is C in. Used all NAND gates here, 7400. Implemented the AND OR gates to NAND gates, which is the universal gate. Anyway, so our first set of inputs is 0, 0, 0. Sum is supposed to be 0, C out is supposed to be 0, according to our truth table, and that is correct. Next set of inputs, 0, 0, 1. Sum is 1, C out is 0. Next set of inputs, 0, 1, 0. Sum is 1, C out is 0. Next set of inputs, 0, 1, 1. Now for 0, 1, 1, sum has to be 0, and C out has to be 1. Our next set of inputs, 1, 0, 0. Sum is 1, C out is 0 according to our truth table, which is right on our outputs. Next set of inputs, 1, 0, 1. Sum is 0, C out is 1. Next set of inputs, 1, 1, 0. Sum is 0, C out is 1. And our last set of inputs, 1, 1, 1. And both sum and C out are supposed to be 1. Now this is just the first part. I haven't connected our C out and my other inputs to the full 4-bit binary adder to make a 5-bit, but that'll be in the next part. So this is part 2 of lab 2. I've already recorded this, but I found the mistake. Could not fix it, so I'm going to try to get as much points as possible by doing what I can. So to note that this is S0, S1, S2, S3, and this is our sum 4, which is our carry. This first switch right here, this switch 1, that's our A0. This switch is our A1, then A2, and A3, and then the second switch is B0, and this switch is B1, B2, and B3. So we can add simple numbers like, 1 and 1, we get 2. Let's see that again. So our A is 1, and our B is 2. Or A is 1, B is 1, so 1 plus 1 is 2, which is right. Let's say we want to add big numbers like 9. So we set 8 and 9. So this is 1, it's 8. And then for B, we want 7. Set this here, 1 there. These switches, and we got a carry because it's only a 5-bit adder. Oh yeah, so a 4-bit adder plus a 5-bit adder. Let's say we want bigger numbers. Let's go past 16. The instructions are set to do 12 plus 7, so let's make A 12. So we'll go here. 8, 4, which is 12, and then for B, we want 7, so we do have a carry, but since we have a number larger than 16, we also have 3 here, because 16 plus 3, 12 plus 7 is 19. Excuse me. Other combinations we can do, like we can set them all to equal 15, so we get 30. So set all up. We have the carry and then our leftover bits, and then basically adding Adding any binary number to 0 is obviously we're going to get to that binary number. This is 15. If we put one more, then we get 16. If we put another 2, 16 plus 2, 18. What else we got? 16 plus 4 is 20. And 20 plus 8, 28. If we have more adders, we could probably get bigger numbers. But that's all mostly I can do. Hopefully it doesn't impact my grade that much. So this is the end of lab 2.